Dear students, today we will continue trigonometric functions of R.D. Sharma, chapter 5, exercise 5.1. Prove the following identities. Identities are given below, we have to prove them. Question number 7. Sin cube x plus cos cube x upon sin x plus cos x plus sin cube x minus cos cube x upon sin x minus cos x is equal to 2. So for proving this, just take left hand side. LHS is equal to sin cube x plus cos cube x upon sin x plus cos x plus sin cube x minus cos cube x upon sin x minus cos x. This is our left hand side. Now for proving this equal to 2, here we can apply the identity a cube plus b cube, and here a cube minus b cube. Both identities we can apply here. So what are the identities? Since a cube plus b cube is equal to a plus b into a square plus b square minus ab, and a cube minus b cube is equal to a minus b into a square plus b square plus ab. Now use these identities in numerator. So left hand side will become sin cube plus cos cube. We can write sin x plus cos x into sin square x plus cos square x minus sin x into cos x upon denominator as it is sin x plus cos x. In second term, apply the identity a cube minus b cube. So a minus b sin x minus cos x into a square plus b square plus ab. So sin square x plus cos square x plus sin x into cos x. Denominator as it is sin x minus cos x. So in both terms we applied the identities whole a cube plus b cube and a cube minus b cube. Now this sin x plus cos x and sin x plus cos x gets cancelled. Sin x minus cos x, sin x minus cos x cancelled, which is equal to this sin square x plus cos square x is the Pythagorean identity. So it is 1 minus sin x into cos x plus here again the same identity sin square x plus cos square x is equal to 1 plus sin x into cos x. Now again this positive sin x cos x and negative sin x cos x gets cancelled. So 1 plus 1 2, which is equal to right hand side. So in this way we can prove this identity. Question number 8. Sec x into sec y plus tan x into tan y whole square minus sec x into tan y plus tan x into sec y whole square is equal to 1. So for proving this, taking LHS, left hand side is equal to sec x into sec y plus tan x into tan y whole square minus sec x into tan y plus tan x into sec y whole square. This we have to prove equal to 1. So notice both the terms here, sec x sec y, tan x tan y sec x tan y tan x sec y. So here whole square, if we are opening this two brackets by using the identity a plus b, then we will get the terms sec square and tan square, and we have the identity in terms of sec and tan. 1 plus tan square theta is equal to sec square theta. That identity we can apply here for proving 1. So apply the identity a plus b whole square in both the brackets. So identity is, since a plus b whole square is equal to a square plus b square plus 2ab. This identity we can apply in both the brackets. So LHS will become is equal to sec square x sec square y plus b square, so tan square x tan square y plus 2ab, 2 sec x 2 sec x sec y into tan x tan y minus, in second bracket again apply the identity a plus b whole square. So sec square x tan square y plus b square, so tan square x sec square y plus 2ab, 2 sec x tan y into tan x sec y. Now open this bracket multiplying by minus sign. So this is sec square x sec square y as it is plus tan square x tan square y as it is plus 2 sec x sec y as it is into tan x tan y, multiplying by minus sign minus sec square x tan square y minus tan square x sec square y minus 2 sec x tan y into tan x sec y. Now notice any term is cancelling here. Notice this is 2 sec x sec y tan x tan y. This is minus 2 sec x sec y and tan x tan y. So this 2 we can cancel. 2 times sec x sec y tan x tan y minus 2 times sec x sec y tan x tan y, cancelled. Now write this remaining terms, sec square x sec y sec square y plus tan square x tan square y minus sec square x tan square y minus tan square x sec square y. Now this sec square x sec square y, here sec square x tan square y. So from this two term we can take out common this sec square x common from here and here, so which is equal to sec square x common, so here sec square y left, here minus tan square y left. In next two terms, here tan square x tan square y minus tan square x sec square y. So from here we can take common tan square x from here and here. So take out tan square x common, tan square x common, so tan square y left and here minus sec square y left. Now recall the identity, 1 plus tan square theta is equal to sec square theta. This is Pythagorean identity. Shift this tan square theta this side. So therefore 1 is equal to sec square theta minus tan square theta. So sec square theta minus tan square theta can be written 1. So here sec square y minus tan square y, it will be 1, and tan square y minus sec square y. So we can write this minus 1 sec square x, sec square y minus tan square y 1. From here take out minus sign common so that it will become sec square theta minus tan square theta form. So we can take out minus sign common. So minus tan square x, and write this sec square y minus tan square y after taking out minus sign common. Now we can write this bracket sec square y minus tan square y as 1. So which is equal to sec square x minus tan square x, and this bracket is 1. So sec square x minus tan square x, again we can apply the same identity, sec square theta minus tan square theta 1. So sec square x minus tan square x will become 1, which is our right hand side. In this way we can prove this identity. Question number 9. Cos x upon 1 minus sin x is equal to 1 plus cos x plus sin x upon 1 plus cos x minus sin x. Here this right hand side is looking lengthy, so we can take this right hand side. RHS is equal to 1 plus cos x plus sin x upon 1 plus cos x minus sin x. So for simplifying this, or for getting this left hand side, we have to rationalize this. So for rationalizing here 3 terms, so we can make 2 terms. This 1 plus cos x minus sin x. So consider this is one term and this is second term. So this is a minus b. So for making the identity in denominator a minus b into a plus b, we have to multiply by a plus b and dividing by a plus b. So here this is minus sign. So just change this sign and multiplying and dividing by this. So 1 plus cos x, we can put in bracket, plus sin x upon 1 plus cos x minus sin x. Now rationalize this. 1 plus cos x plus sin x dividing by same 1 plus cos x plus sin x. This is called rationalizing the denominator. By rationalizing the denominator. By rationalizing the denominator. Now we can solve this. In numerator a plus b, same quantity, so we can take whole square. 1 plus cos, so in numerator this is 1 plus cos x plus sin x whole square. Same quantity coming 2 times, so we can take whole square upon, and denominator a plus b, a minus b, a plus b, and denominator a minus b, a plus b. So apply the identity a plus b into a minus b, since a plus b into a minus b is equal to a square minus b square. This algebraic identity we can use in denominator. So it is 1 plus cos x whole square minus b square sin square x. Now simplify this. In numerator, apply the identity a plus b whole square. A square, so 1 plus cos x whole square plus b square sin square x plus 2ab. So 2, 1 plus cos x into sin x upon, and denominator again open by a plus b whole square, a square plus b square plus 2 times ab, 2 into 1 into cos x minus sin square x. In numerator and denominator we applied the identity a plus b whole square is equal to a square plus b square plus 2 times ab. This identity we applied in numerator and denominator. Now simplify this, which is equal to, again apply the identity a plus b whole square, a square plus b square plus 2ab. So this is 2 cos x plus sin square x. Here multiply by 2 sin x. So 2 sin x plus 2 sin x into cos x upon 1, this minus sin square x right here for making the identity, plus cos square x plus 2 cos x. Now this sin is cos square x plus sin square x, we can write one, so write them close to each other. So first sin square x plus cos square x plus this one as it is, and plus this 2 cos x as it is, plus this 2 sin x as it is, and this last term 2 sin x cos x as it is. 2 sin x into cos x upon, here this 1 minus sin square x, we can write cos square x by using the identity sin square theta plus cos square theta is equal to 1. So 1 minus sin square x can be written cos square x plus cos square x as it is plus 2 cos x. In numerator, again apply the identity sin square x plus cos square x is equal to 1. So 1 plus 1 plus 2 cos x plus 2 sin x plus 2 sin x into cos x. And denominator cos square x plus cos square x 2 times, so 2 cos square x plus 2 cos x. Now simplify this further, which is equal to 1 plus 1 2 plus 2 cos x plus 2 sin x plus 2 sin x cos x upon, here we can take out 2 cos x common. So 2 cos x common, so here 1 cos x left and plus 1 left. In numerator, first take out 2 common throughout. 2 common, so 1 plus cos x plus sin x plus sin x into cos x upon 2 cos x into cos x plus sin x, cos x plus 1. So this 2 cancelled. So in numerator, this is 1 plus cos x. From this two terms, take out this sin x common. So it will become 1 plus cos x. So that we can take out the bracket 1 plus cos x common. So which is equal to 1 plus cos x as it is, plus take out sin x common from last two terms. So 1 plus cos x upon cos x into cos x plus 1. Now we can take out this factor 1 plus cos x common from numerator. So which is equal to 1 plus cos x common. So in this bracket 1 left and here sin x left plus sin x upon cos x into cos x plus 1. Now this bracket cos x plus 1 and cos x plus 1 are 1 plus cos x is the same thing, we can cancel. So we have got 1 plus sin x upon cos x. Now check, but we have to prove cos x upon 1 minus sin x. So we have to solve it further. In denominator cos x is coming, in numerator 1 plus sin x, but in our left hand side in numerator cos x is there. So multiplying and dividing by cos x. For making numerator cos x, we have to multiply and divide. Again we are rationalizing this. 1 plus sin x upon cos x, multiplying by cos x and dividing by cos x. So this is cos x into 1 plus sin x upon cos square x. But in numerator we require 1 minus sin x, so write this cos square x as this is cos x 1 plus sin x. In denominator we need 1 minus sin x. So cos square x can be written 1 minus sin square x by using Pythagorean identity. Since sin square theta plus cos square theta is equal to 1. So from here cos square theta is equal to 1 minus sin square theta. Now this 1 minus sin square x, so this is cos x 1 plus sin x, and this 1 minus sin square x, we can write this 1 as 1 square. So we can make the identity a square minus b square is equal to a plus b into a minus b. So this denominator can be written 1 plus sin x into 1 minus sin x. Now this 1 plus sin x gets cancelled. So we have got cos x upon 1 minus sin x. This is our required left hand side. Cos x upon 1 minus sin x. So in this way we can prove this. Question number 10. Tan cube x upon 1 plus tan square x cot cube x upon 1 plus cot square x is equal to 1 minus 2 sin square x cos square x upon sin x cos x. So for proving this side is looking little bit lengthy and power cube here, so we can take this left hand side. Taking LHS, tan cube x upon 1 plus tan square x plus cot cube x upon 1 plus cot square x. So recall the Pythagorean identities. We had these two identities. Since 1 plus tan square theta is equal to sec square theta, and 1 plus cot square theta is equal to cosec square theta. So we can apply these two identities and denominator. So this left hand side will become tan cube x upon 1 plus tan square x can be written sec square x, plus this cot cube x as it is upon 1 plus cot square x can be written cosec square x. Now for proving left right hand side, we can convert them into sin cos. So this tan cube x can be written sin cube x upon cos cube x, and this sec square x can be written 1 upon cos square x, plus this cot cube x can be written cos cube x upon sin cube x upon cosec square x can be written 1 upon sin square x. Now simplify this. They are double fractions, so this cos square x will shift in this numerator and this cos cube x in denominator. Similarly, sin square x in numerator and sin cube x in denominator. So we can cancel them here only. This cos square x and this cube power. So here one cos x is left. We cannot cancel them, but we are subtracting the power, or we can write this cos cube x as cos square x into cos x, so one cos square x will be cancelled. Similarly here sin cube x can be written sin square x into sin x, so this sin square x and sin square x will be cancelled and one sin x will be left. So which is equal to sin cube x upon one cos x left here, cos x, plus in second term this sin square x and this cube cancelled, so here cos cube x upon this sin x. Now simplify this. Now we can take the LCM. LCM of sin x and cos x is sin x into cos x. Cancel by this cos x cancelled. Multiply sin x into sin cube x, so it will be sin raised to the power 4x plus sin x cancelled, cos cube x into cos x, cos raised to the power 4x, which is equal to this sin raised to the power 4x we can write sin square x whole square, and cos raised to the power 4x we can write cos square x whole square upon sin x into cos x. Now in numerator we can apply the identity a square plus b square. Since a square plus b square is equal to a plus b whole square minus 2 times ab. This identity we can apply here. So a is equal to sin square x, b is equal to cos square x. So which is equal to a plus b whole square. So sin x, sin square x plus cos square x whole square minus 2 times ab, 2 sin square x into cos square x divided by sin x into cos x. Now here sin square x plus cos square x is equal to 1, which is equal to sin square x plus cos square 1 square minus 2 sin square x cos square x as it is upon sin x into cos x. Here we applied Pythagorean identity. Sin square theta plus cos square theta is equal to 1. This we applied here, which is equal to 1 square 1 minus 2 times sin square x into cos square x upon sin x into cos x. So which is our right hand side. Question number 11. 1 minus sin square x upon 1 plus cot x minus cos square x upon 1 plus tan x is equal to sin x into cos x. So taking left hand side, LHS is equal to 1 minus sin square x upon 1 plus cot x minus cot square x minus cos square x upon 1 plus tan x. So convert this cot and tan into sin cos first, which is equal to 1 minus this sin square x as it is upon 1 plus cot x can be written cos x upon sin x. Cos x upon sin x minus this cos square x as it is upon 1 plus tan x can be written sin x upon cos x. Now we have to simplify this, which is equal to 1 minus sin square x and denominator take LCM. LCM is sin x. So this is sin x plus cos x minus sin as it is, numerator as it is cos square x and denominator LCM cos x. So this is cos x plus sin x. Now this is double fraction. So shift this sin x into numerator and this cos x into numerator, which is equal to 1 minus sin square x into sin x sin cube x upon sin x plus cos x minus this cos square x into cos x cos cube x upon cos x plus sin x. So here in denominator this sin x plus cos x and this sin x plus cos x, we can take the LCM or we can take out common. So here we can take the LCM. Take LCM. LCM of sin x plus cos x and cos x plus sin x is sin x plus cos x only. One time we can take because both the terms are same. So this dividing by 1, sin x plus cos x, multiply this into 1. So this is sin x plus cos x. Dividing by this 1, 1 into minus. So minus sin cube x and this is minus cos cube x. Now which is equal to sin x plus cos x. Take minus sign common from these two terms. So sin cube x plus cos cube x upon sin x plus cos x. Here we can apply the identity a cube plus b cube. This is sin x plus cos x. We can write in bracket minus sign a cube plus b cube, a plus b. So sin x plus cos x into a square plus b square minus ab. So a square sin square x plus b square cos square x minus ab minus sin x into cos x upon this sin x plus cos x as it is. Now here we can take out this bracket common and this sin square x plus cos square x we can write 1. So this sin x plus cos x common from here and here. So here one left, this minus sign, and this sin square x plus cos square x we can write 1. So multiplying this minus sign, so this is minus 1, and minus sin x cos x will become plus sin x into cos x upon sin x plus cos x. This sin x plus cos x gets cancelled, minus 1 plus 1 cancelled. So finally sin x plus sin x into cos x, which is our right hand side. Question number 12. Prove that 1 upon sec square x minus cos square x plus 1 upon cosec square x minus sin square x into sin square cos square x is equal to 1 minus sin square x into cos square x upon 2 plus sin square x into cos square x. So taking left hand side, 1 upon sec square x minus cos square x plus 1 upon cosec square x minus sin square x into sin square x into cos square x. So for proving this into sin square and cos square, convert this sec square x and cosec square x into sin cos, which is equal to 1 upon the sec square x can be written 1 upon cos square x minus cos square x as it is plus 1 upon this cosec square x can be written 1 upon sin square x minus sin square x multiplying by sin square x into cos square x as it is. Now take LCM. 1 upon here LCM is cos square x. So 1 minus cos raised to the power 4x plus, again take LCM in denominator, 1 upon LCM is sin square x 1 minus sin raised to the power 4x into sin square x into cos square x as it is. Now they are double fraction, so shift this cos square x into numerator and sin square x into numerator. So we can write them cos square x upon 1 minus cos raised to the power 4x plus, similarly in second term, sin square x into 1 sin square x upon 1 minus sin raised to the power 4x is into sin square x into cos square x. Now simplify this. Now we can take LCM 1 minus cos raised to 4x into 1 minus sin raised to 4x. 1 minus cos raised to the power 4x into 1 minus sin raised to the power 4x. This is LCM. Dividing by this cancelled. 1 minus sin raised to 4x into cos square x. Cos square x into 1 minus Sine raised to the power 4x plus 1 minus sine raised to the power 4x cancelled. 1 minus cos raised to 4x into sine square x. Sine square x into sine square x into 1 minus cos raised to the power 4x into sine square x into cos square x, which is equal to, multiply this cos square x, so cos square x minus cos square x into sine raised to the power 4x multiply by sine square x minus sine square x into cos raised to the power 4x upon 1 minus cos raised to 4x, we can write 1 square minus cos square x whole square into 1 square minus sine square x whole square into sine square x into cos square x. Now this sine square x plus cos square x we can write 1. So write them close to each other. So sine square x first plus cos square x, and from this two terms cos square x sine raised to the 4x sine square x cos raised to the 4x, we can take out minus sine square x cos square x common, minus sine square x cos square x common. So here sine square x left, when we multiply then sine raised to 4x cos square x minus, from here sine square x common, cos square x common, so plus cos square x left upon, in denominator we can apply the identity a square minus b square, a plus b into a minus b, so it is 1 plus cos square x into 1 minus cos square x into 1 square minus sine square x, this is a square, this is 1 square minus sine square x whole square. So 1 square minus sine square x square, 1 plus sine square x, 1 plus sine square x into 1 minus sine square x into sine square x into cos square x, which is equal to this sine square x plus cos square x will become 1. This is 1 minus sine square x into cos square x, and this bracket also sine square x plus cos square x 1 upon this 1 minus cos square x. 1 minus cos square x can be written sine square x, and 1 minus sine square x can be written cos square x. So 1 plus cos square x as it is, 1 minus cos square x sine square x into 1 plus sine square x as it is, and 1 minus sine square x can be written cos square x into sine square x into cos square x. Now cancel this sine square x, cos square x, sine square x, cos square x, which is equal to 1 minus sine square x, this is cos square x, into cos square x upon 1 plus cos square x into 1 plus sine square x. Check what we have to prove. And the numerator terms came 1 minus sine square x cos square x, and denominator 2 plus sine square x cos square x. So open these two brackets, which is equal to 1 minus sine square x into cos square x upon multiplying by 1 plus sin square x multiplying by cos square x plus cos square x into sin square x, or we can write sin square x into cos square x. Now this sin square x plus cos square x 1, which is equal to 1 minus sin square x into cos square x upon 1 plus sin square x plus cos square x, again 1, and this sin square x into cos square x, which is equal to 1 minus sin square x into cos square x, as it is 1 plus 1, this 1 plus 1 2, plus sin square x into cos square x, which is equal to right hand side. 1 minus sin square x, 1 minus sin square x cos square x upon 2 plus sin square x into cos square x. Hence proved. So I think it's enough for today. The remaining questions of this exercise we will solve in next class.